Thanks for the reminder. I appreciate it. All right, so all right, somebody in the chat says, oh, Regression Line. All right, the least squares regression line is the line that minimizes the sum of the squared errors or residuals. And I underline residuals. We're going to come back to that sometime soon in another problem, but we'll see how to calculate residuals. The line that is also the line that best describes or best explains the relationship of the data. So let's say if I had my data, my scatter plot like this, the least squares regression line would be the line that's in the middle of that. That basically, um, it will not hit every single point. So it's impossible for it to hit every single point if it's a straight line, but it's a line that best explains or summarizes the relationship of the data. All right. All right, so finding the regression line, you'll be able to find a regression line by using this relationship right here. That's y hat equal to b1 times x plus b0 or b naught. Just depends on which one you want to use. So y hat is your predicted y. So what we're going to do and use this, and I didn't put this up here, I'll put it at the bottom because I meant to write this when I first mentioned regression line. Regression line is used to predict based on. All right, so we're going to use it to predict an observation based on previous observations. So we will be able to predict the y according to the data values that we have already seen. So that b1 in the formula that's connected to x is going to be r times s sub y over s sub x. And in my math lab, if they ask, b1 is your slope. And then b naught is y bar minus b1 times x bar. And that is your y-intercept. All right. Like I said, just in case my math lab were to ask you. All right. And so the other letters, the R is your correlation coefficient. We got that from last class. X bar. We talked about X bar. That's your mean. But in this case, it's going to be the mean of your X values. S sub X is the standard deviation of your X values. Y bar will be the mean or average of your Y values. And then S sub Y is the standard deviation of your Y values. All right, so before we do an example, any questions on anything I've written?
Nope.
Mm-hmm. Okay, we'll do that. All right, so they ask us to find a regression line. They give us R, X bar, S sub X, Y bar, and S sub Y. So correlation coefficient, the average of your X values, standard deviation of your X values, average of your Y values, standard deviation of your Y values. So we can use the relationships that we just introduced to find our regression line. So we need to find B1 first. Also, just throwing it out there, if by some chance I miss you as far as attendance is concerned, make sure you are active in my math lab so that I can see that you, or count you for being here or being active in class. So, because remember, I need to at least see your name in my math lab. There's no way for you to pass the class if you aren't in my math lab. So make sure you're at least getting in my math lab and doing some work. It doesn't have to be every day. Doesn't have to be every other day, but at least if I see you in there doing stuff, then I can, give an account of you being here, just in case I were to miss you in the Zoom sessions. All right, so let's find B1.
Sorry about that, sir.
Oh, oh no, you're fine. No, I wasn't saying that specifically to you, sir. I wasn't calling out anybody. I was just saying in general.
Oh.
Yeah. I was just saying just to make sure um, you guys are active in my math lab, so that if I were to miss you in Zoom, as far as attendance was concerned, I could still,
Okay.
because I check both of them as far as attendance.
I missed the first 16 minutes. Had to reset my password.
Yeah, man, you all good? Yeah, it's not a
Okay,
problem at
thanks,
all.
sir.
Yeah, not a problem.
I'm out.
So, so we're looking at B1. That's R times S sub Y, and they gave us all these values. They didn't ask us to calculate. They gave us these values, so we use them accordingly. All right. So make sure you know how to use your calculator. Throw those numbers into the calculator, and that will give us negative 2.167. Was someone saying something?
See, are you referring to me with the calculator?
Oh, see, everybody think I'm taking shots at them. I'm not taking shots at anybody. I'm just talking. No, I was not talking to you, ma'am. So now that we have B sub 1 or B1, depends on how you want to say it, we can find B naught or B0. That's Y bar minus B1 times X bar. So you notice why we had to find B1 first, because B1 is a part of B naught's formula or relationship. So Y bar is 10, B1 is negative 2.1676, and X bar is 4, and that is 18.6704. So now that you have B1, B sub 1, and B sub 0, you now have the pieces that you need for your regression line. Your regression line formula is Y hat equal to B1 X plus B0. So you just plug in those values. B1 is negative 2.1676 X plus 18.6704. And my math lab will let you know how many decimal places they want you to go out. They probably do something like this. Something like that. Or they may have it so that you couldn't put in X, but something like that. And they'll say round to 3 decimal places or round to 4 decimal places. And you'll put them in accordingly. So. Also recognize that this could have been written this way. That's the same thing. Notice that 2.1676 is still negative. 18.6704 is still positive. And also the 2.1676 is the term that's connected to X. So nothing changed. It's just that you moved your terms around. All right. Questions.
No.
All right. So that's one way they could ask you to find a regression line. So if they give you correlation coefficient, X bar, S sub X, Y bar, S sub Y, that's one way they could ask you to find a regression line. The other way, and I'll say this before I go to the other way, if they give it to you in that way, would they give you the correlation coefficient, X bar, and all the stuff like that, then you would just follow the formula that I just gave. Now, the other way they could give it to you is that they give you the data values. So they don't give you R, X bar, S sub X, Y bar, S sub Y. They just give you a list of data values and then say find the regression line. So that's the way we'll look at it. This next one. Determine the residual for the predicted value from the result. See, okay, that's good. And all right, so we want to find a regression line. Then we're going to predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. Then we're going to determine the residual for the predicted value from the resultant C. Is the distance in the table above or below average among balls hit at 103 miles per hour? All right, so this is the same chart. If you don't want to write it over, that's fine. It's the same chart from last class. Looking at the club head speed, talking about golf. All right, so we have 100, 102, 103, 101, 105, 100, 99, 105, 257, 264, 274, 266, 277, 263, 258, 275. All right, so these are our X values. These are our Y values. Remember we talked about last class, this is our explanatory variables. The other is our response variables. And if I'm not mistaken, let me check one thing as far as what I gave you guys last class. Okay, I just want to make sure I gave you that explanation. Okay, so we talked about the difference between your explanatory and your response variable. So it does matter which one is your X, which one is Y. How fast you hit the ball or how hard you hit the ball is going to explain how far the ball travels. So this is our explanatory variable. This is our response variable, or this column. This column. Okay, so just going back there for a second. So now we have this chart, we have these data values. So what I would do is I would Google regression, and let me see, did it share? Yeah, okay, just making sure you guys can see it. So regression line, and so notice, like I said before, I like to do easycalculation.com. But if you do regression line calculator, a lot of different things will pop up. But here it goes. And just like oh, did they change it for me? Let me see something. Okay, I'm about to say, yeah, this is what I need. So notice we have our two columns, X values, Y values, explanatory variables, and we can add or take away the rows as needed. So you type them in. I lost my chart.
What website is that again?
Easycalculation.com. I think I put too many in there. That's all right. All right, so let me make sure I got my data correct. So we have 100, 257, 102, 264, 103, 274, 101, 266, 105, 277, 100, 263, 99, 258, 105, 275. Okay, so those are my values. Calculate. So notice it's 8 total numbers. We talked about that last class, 8 different observations here. My slope, which is B1, y-intercept B0, and then they put it in equation form right here. All right. And once again, my math lab will let you know how many decimals you need. So let's go back to the notes.
Wish I had this when I was doing slopes and y-intercepts and quantitative reading.
So you gonna keep on beating that dead horse, right?
I'm just saying. I'm being very honest. My thing is you're only gonna learn as well as you're taught.
Uh-huh, I agree.
And if you're not being taught right, it becomes frustrating.
Yeah, yeah.
Well, I just pretty much skipped over slopes and intercepts on all the homework assignments in that class
Mm,
because I just couldn't get the help I needed to.
right.
Yeah.
Sorry to hear that.
I still passed the class though, but I'm just saying I would like to have learned it.
Right, right. That's tough. That's tough. And it's hard to keep talking about it without talking about my colleagues. So
I ain't
I'm
giving no names. I'm just and I'm gonna leave that horse alone. Quit beating.
right. So, so once again, just take note of the different way that they could give you the information as far as finding your regression line. Remember the last one they gave was the correlation coefficient, the average of your x values, standard deviation of x values, average of your y values, standard deviation of the y values. So since we had that information, we went ahead and used the formulas that they gave. In this one, they gave us the data set, so we went ahead and plugged it into calculator, Apple website, whatever you decide to use. Remember, you do not have to use easycalculation.com. You can use whatever you like as long as it is reliable. So through your homework, you should be able to find out if what you're using is reliable or not. And you will have your regression line. And like I said, it could give you in either one of these forms. Just notice that my 3.166 is still attached to my X, no matter whether it's first or last. And my 55.797 is negative, no matter whether it's in front or behind. So, all right. Let's look at B. It tells us to predict. So we're going to use this equation. It says predict the distance a golf ball will travel when hit at the club head speed of 103 miles per hour. So that means X is 103. Remember, that is our X. Club head speed is our X. So they're saying if you do hit it at 103, what does this equation predict would be the distance or the outcome? I think I'll stick with writing 3.1 first. Doesn't matter though. So you plug in 103 for X. And your result should be 270.3 yards. So what this result says that on average, let's say if you hit the ball at 103 miles per hour 10 times on average, take all those results on average, you would get 270.3. So nothing is perfect. We aren't perfect. So you hit it at 103. Maybe the wind is blowing and it may go a little further, or it may be shorter because the wind is blowing the opposite direction. Any factors could be in play. You hit it at a different angle as far as the club is concerned. But it's still on average, it would be 270.3. I think that's all B asked for. Yep. So now C, last one, determine the residual for the predicted value found in C. So that's the first part. So we mentioned residual earlier. Residual and error are the same thing. And it is your observed Y. Observed Y. Let's see if I can fit it up here. Observed Y minus. predicted. So that's our observed y minus our predicted y. So that's just y minus y hat. If we just want to break it down to symbols. So y hat we see is 270.3. In order for us to be able to have an observed y, then we would have had to have hit it at 130. That's at 130, 103, and have an actual outcome measured. And we do have that right here. So our observed y is 274. And I'll stay with black. So this came from the chart. This came from the equation. Subtract the 2, and we should get 3.7. So that is the residual. Let's see what it has above, right? It has above below average. Yep. All right. So, and let me write this. All right. So because it is positive, because 3.7 is positive, the observation in the chart is above average balls hit at 103 miles per hour. Now, if it was negative 3.7, then we would have said it was below average. All right, questions? Any questions?
Nope.
All right. So with that being said, let's do 4.3 is very short. Only one type of thing that they're talking about in there. So 4.3, and then next class would just be a review day. So you can bring whatever questions you have from whatever sections to next class. I won't do anything new unless y'all want something new, but we will be done with chapter 3 and chapter 4 at that moment. So like I said, I won't do anything new on next class, and it will be your opportunity to ask questions. And if you don't have any questions, that's fine as well. But just telling you, I'm giving you that option for
And you
next
said
class.
test 1 pretty much is definitions.
Yep, definitions, some graphs.
Okay.
So yep, if you take a look at it and you have any questions, you can always ask that on next class as well. All right, so the coefficient of determination, it measures the proportion of total variation in the response variable that is explained by the regression line. So it basically tells us how reliable the regression line is. No, not coefficient. Wrong one. Correlation. So it is the correlation coefficient squared. That's our lowercase r that we were dealing with up to this point. So no serious calculation there. All we're going to do is square our correlation coefficient. It's denoted by capital R squared. All right, so I think I mentioned this, but it is denoted by capital R squared. It is between 0 and 1 inclusive. So it can be equal to 0 or 1, but for the most part, it will be in between 0 and 1. If R squared is equal to 0, the regression line has no explanatory value. In other words, the things that we did last section, trying to explain or predict, would mean nothing because the reliability of your regression line is 0%. But if R squared is equal to 1, which would represent 100%, the regression line explains 100% of the variation in the response variable, which also means that it is going to explain or predict 100% of the time correct. So very rare would that occur. But yep. Let's see, is there anything else before we do this? I think we are good to go before we do an example. All right, so we want to determine and interpret the coefficient of determination for the club head speed versus the distance. All right, so it's the same chart from earlier, same chart from last class. First thing we'll do is find the correlation coefficient, which is R, and we did that back in 4.1. We used that same chart. And remember, you would throw those data values into an app, website, or calculator, just like I did earlier with the regression line to find the correlation coefficient. And that will be 0.939 for us. So next you want to find the coefficient of determination. The way you would do that is square your correlation coefficient, which is R. And my math lab will let you know if they want decimal or percent. Remember, you want to find. Say it again.
I was trying to remember. I already did this one. I think they wanted the decimal.
Okay.
And then the percentage.
Gotcha. All right. So once you have that, now you can interpret. All right, so a couple things here. 88.2% of All right, so 88.2% of the variation in the distance is explained by the regression line. 11.8% of the variation is explained by other factors. So it just means that a regression, I meant to put a regression line. The regression line has an 88% reliability, 88.2% reliability. All right. Questions on anything I've written so far?
Yep.
Mm-hmm.
So how you got that 11.8? Was that just a subtraction of the 88.2 from 100%?
You got it.
Okay. Y'all gonna look around. I'm gonna be doing calculus next.
Ain't nothing wrong with that. Need help with calculus? I got you.
No thanks.
All right. Anybody still copying before I turn from this page to show you one last thing?
Sir, I have a question.
Yes, sir.
When you say divided by, like you have 2.44 and then you have a number like 40%.
Okay.
Which one goes in the division box?
Okay. Let me make sure I got you. So you say you have
Just
2.44.
say,
Mhm.
just say that 88%,
Mm-hmm.
and you want to find what percentage it is of 100. I just don't remember which one goes in the percentage box.
Okay. So it's a couple, you said a couple different scenarios here. So let me make sure I got your question. So
Yeah, I'm sorry about this.
oh, no, you're fine. You're fine. So I answer, I hear two different questions. So let me answer both of them and see if that explains what you're saying. So now, if I have 2 divided by 3 and I want to set it up long division,
Yes.
that 3 is going on the outside, the 2 goes in the division, under the
Okay.
division bar. Uh-huh. Now you can put it in the calculator this way, and that, you know, if you're using the calculator, that's fine. 2 divided by 3, hit 2, hit division bar, hit 3, is going to come out okay. Now, if you want to do it by long, long hand, or by hand, long division, the 2 will go under the bar, and then the 3 will be on the outside.
Okay, the 2's under.
Mm-hmm. So if
Thank
I
you.
have, yep, no problem. If I have 10 over 7, that's the same setup as 10 divided by 7, which means I will have the 7 on the outside, 10 under.
Got you.
All right. So
Thank
now
you,
there was,
sir.
yeah, not a problem, not a problem. So just in case anybody else heard this and then heard the other question he asked, which I don't think was related to this, but I'll go ahead and address it anyway. Let's say if I wanted to take 88, and I'll just leave the 0.2 off, 88% of, let's say, 500 of in mathematics means multiplication. So in actuality, once you said 88% of something, you went from, you're not talking about division, you actually talked about multiplication. You have to convert this to a decimal as well before you do your calculation. So that'll be 0.88, and that'll be times 500. So just throwing that out there. I heard the terminology, so I was just making sure we were clear on how to take care of this stuff.
Okay, I love you. Thank you.
Love you too, sir. All right, so let's look at this real quick. Want to make sure. Didn't I have my math lab window open? I thought I did. So let me open one. Give me 1 second. Mm. 'Cause that. Here we go. All right, so some people have already sent it to me, and for those who have sent it, I have seen it. I just haven't put them in the grade book yet, so plan on doing that between the next few days. But assignment 1 is right here. 4 problems out of chapter 3, and assignment 2 is just 3 problems out of chapter 4. Just emphasizing correlation coefficient, which is is out of 4.1. Regression line, which is out of 4.2, and then coefficient of determination, which is the last thing we did, out of 4.3. So all together, just 7 problems. Like I said, 4 out of assignment 1, and then 3 problems out of assignment 2. So try those problems out, see if you get stuck. This would be a great weekend for you to do that, because you can try them out, check the answers in the back of the book. Because remember, I told you they're odd, so the answers are in the back. See if you get those answers. If you can't figure out how those answers were gotten, then feel free to ask me those questions on next class, and we'll make sure you ironed out, all details are ironed out before we leave on next class. Questions?
Can those be the only 3 assignments we have this semester?
I don't know. I'm not sure.
It's too much
And
on the other homework.
I know. I might not do any more. I might not even do this chapter 7 one, but I know I at least want to do assignment 1 and assignment 2, to kind of ensure that you guys are okay with the topics. So yeah. And it's only 7 problems. It's only 7, and you got the answers to them. So really, truth be told, if you want to finesse the system and just write down, you got the answers. I mean, I don't know what else to do for that. So questions, concerns, comments before we close out today?
Thank you, sir.
No problem. No problem.
You stopped me from having to ask my daughter.
You're most definitely welcome. Most definitely welcome.
Have a good weekend.
All right, you do the same. If you all are good, if everybody's good, have a great weekend. Be safe. I will see you on next class.
You too. Have a good weekend.
All right. Take care.